If you want to figure out the graph of gx from the original function at brackets kx k greater than 0, you may consider the question follow the following steps. Okay, first, in the Cartesian plane, you can assume this is the original function f(x), but you need to know here we should consider kx as a whole, so for this function is original function should be f(x). That you say we need to use k times x equals the original x0 on the original function's graph. Here it should be f(x0). So kx equals x0. So x equals x0 over k. Now we need to divide the situation into two situations. If k greater than 1, you should not forget k should be a positive number. So first we consider k greater than 1. That you say for the same y coordinate, if we want to figure out the same y coordinate, here x0, that you say f(x0), we need to guarantee this equation existing. So x equals this one. We can figure out this kx equals x0. So f(kx) equals f(x0). So from this equation, we can figure out this y coordinate should be equal to the new curve's y coordinate. But this is the original x coordinate. This is the new x coordinate. But k is greater than 1, so this quotient should be less than x0. This x0 should be greater than this number. So for the same y coordinate, this x coordinate should be on the left side of this x0. That you say it should be here. This is x0 over k. For the other points on the original curve, if we want to keep the y coordinates unchanged, we need to figure out x0 over k. This new x coordinate must be on the left side of this x0, so it should be here. Okay, for every point, for this point, we need to move the x coordinate to the left side. Perhaps it should be here. Okay, this point, this point, this point. Then we need to get the corresponding image points. Then we connect all of the corresponding image points. We can figure out f kx, but k greater than 1. Now, if we consider k here, k greater than 0, less than 1, you can easily find out this number. For this situation, this number x0, if the denominator is a positive number less than 1, so this quotient should be greater than x0. So this number must be on the right side of the x0. So for this original point, if we want to keep the original y coordinates unchanged, we need to figure out x0k, it should be here for the same fx0. This point equals x0 over k. Okay, now we can figure out the corresponding image should be here x0 over k. Here k greater than 0, less than 1. For this k, it is greater than 1. Now, every point on the original graph should be changed like this point. Okay, this point should be here, this point should be here. So every point, the corresponding image should be here. Then we connect all the image points. We can get this curve. That you say, this curve. It should be f kx, but here k greater than 0, less than 1. Now, in summary, you will find out if the coefficient k is the coefficient of x, the change, we describe the changes in horizontal direction. That you say, horizontally, we say this one changes from this one in the horizontal direction. In the horizontal direction, it is compressed. This one changes from the original yellow one. We say it is changed in the horizontal direction. It is stretched. It is stretched. So this one compressed horizontally. This one stretched also horizontally.